Hi, in this video I'm going to solve a problem in which in which an object is hanging from two different ropes at different angles. This is a free body diagram problem. Here it is. Two ropes hold up a 44.5 kilogram sculpture at an art exhibit. One is horizontal and attached to the wall. The other is at an angle of 18.0 degrees from the vertical and attaches to the ceiling. Find the tension in the two ropes. So I'm going to start with a free body diagram. The downward force acting is gravity. There's a tension force from each of the two ropes, so I'm going to call this tension T1. This other tension force is going to be T2. I'm going to do a dotted line for the vertical and the horizontal. And let's just make a note that this angle here is 18 degrees. Okay, let's solve for what we know. And it looks like the only thing we're given is the mass and the angle. So let's solve for the force of gravity. Force of gravity is mg. So it's equal to 44.5 kilograms times 9.81 meters per second squared. That gives us 437 newtons. I'm going to do an extra sig fig and I'll round at the end. 436.5 newtons. So that's 436.5 newtons. And that's all we're given. So let's resolve our vectors into their components and see if we can use Newton's laws to figure some things out. The upward component, I'm going to call that T2x. The leftward component, I'm going to call T2. Actually, I mixed that up. The upward component is in the y direction, so we'll call that T2y, and this is T2x. Okay, so so we would like to be able to solve for T2y and T2x. However, we're not given T2. We're not going to be able to get T2 unless we use something else. So let's use Newton's second law of motion to find something about these ropes. Now in the x direction, we're not going to be able to get anything because there will be too many unknowns. T1 and T2x are unknown. But in the y direction, there will only be one unknown. So let's look in the y direction. Sum of the forces in the y equals MAY. And in the, I'm going to say left is positive since there's no acceleration. So T2x is in the positive direction. Let me correct that. We're looking in the y direction. So I'm going to say up is positive, which means T2y is positive and force of gravity is negative. But since it's suspended, there's zero motion, zero acceleration, which means T2y is just equal to the force of gravity, which is 436.5 newtons. So I'm going to add that to my diagram. 436.5 newtons. Well, we don't yet have the tension. But now that we have one of the sides of that triangle, we can solve for the x component, and we can solve for the overall resultant tension. So I'm going to just redraw the triangle quickly. 18 degrees, 436.5 newtons. This is T2 and T2x. So let's solve for T2x and T2. Since T2 is the hypotenuse and the T2y, the known variable, is the adjacent leg. Hypotenuse and adjacent, that's cosine. So cosine of 18 degrees equals adjacent, which is 436.5 newtons, over hypotenuse, which is T2. Solve for T2, we get T2 equals 436.5 newtons, 36.5 newtons, over cos of 18 degrees, which is equal to 436.5 over cos of 18. 458, or 459.0 newtons. 459.0 newtons. That's going to be one of our answers. We also are going to need to solve for T2x. So since T2x is opposite, and we know the adjacent leg, let's use tangent. Tangent of 18 degrees equals opposite over adjacent, that's T2x over 436.5 newtons, which means T2x is going to end up being equal to 436.5 newtons times tangent of 18 degrees. T2x is then equal to 36.5 tan of 18, 141.8 newtons, 141.8 newtons. So I'm going to put that in my free body diagram as well, 141.8 newtons. Let's just box this part off so we know that it's its own section. Okay, well, the only thing we have left to solve for, since we solved for T2, we know the components of T2. We need to get T1. So since T1 is in the x direction, and since we know all the other forces in the x direction and the acceleration, we can just use Newton's second law in the x direction. So sum of the forces in the x equals ma in the x. The only forces in the x are T1 and T2x. I'm going to choose right to be the positive direction. So we get T1 minus T2x equals mass times acceleration x. Acceleration 0, so that's 0. T1 is just equal to T2x, which is 141.8 newtons. And there we have it, 141.8 newtons. I'm just going to box out our final answers, and that's that. T1 equals 142 newtons. That's the correct sig figs. And T2 equals 459 newtons. So T2 is carrying most of that load. Hope that was helpful. Bye.